So one of the questions I'm frequently asked by dentists is, what is a DC unit or a constant potential unit, and why should I consider it? In this video, I'll describe to you the principle of using high-frequency X-ray generators, their impact on X-ray generation, and the practical implications for intraoral imaging. Now recall the design of an X-ray tube. It consists of a cathode, which is negatively charged, and an anode, which is positively charged. In order to make X-rays, we need a high potential difference between the cathode and the anode. It is this high potential difference that provides the electrons with kinetic energy, and we harness that kinetic energy to make X-rays. We plug our X-ray unit into a wall outlet. This wall outlet provides us with electric power, which is an alternating current. In the United States, this is 110 volts with an alternating current of 60 cycles per second. Integrated within the X-ray unit are transformers and rectifiers. Transformers will increase the incoming voltage to our desired kilovoltage. Rectifiers will change the oscillating alternating current into a more steady flow of current that is applied across the X-ray tube. Such electronics are not used only in X-ray tubes. Power supply units for our electronic devices and phones will modulate the voltage as well as change the alternating current to a direct current. Now let's consider X-ray production in an X-ray tube that is operated with an alternating current with no rectification. As the incoming voltage oscillates, so will the polarity between the cathode and the anode. When the polarity of the voltage across the X-ray tube causes the target anode to be positive and the filament to be negative, electrons from the filament will be attracted towards the positive target and produce X-rays. When the voltage across the cathode and the anode reaches its peak, in this case 70 kilovolts, the efficiency of X-ray production will be the highest. However, during the following half of the cycle, the polarity between the cathode and the anode is reversed and X-ray production ceases. Thus, when we operate an X-ray tube with an alternating current with no rectification, we will produce X-rays for only half of the exposure time. Constant potential or direct current X-ray units use high-frequency power supplies with rectification to provide an almost direct current with less than 2% oscillation of the incoming voltage. Thus, an appropriate potential difference is maintained between the cathode and anode, and X-rays are produced through the entire exposure cycle. So what advantages do constant potential X-ray units offer? First, they require shorter exposure times to produce the same number of X-ray photons. And by using shorter exposure times, we minimize patient motion. By maintaining a more constant potential difference between the cathode and anode with less oscillation, we produce photons with more consistency. This increased consistency is important when we use shorter exposure times, for example with digital sensors. Constant potential X-ray units produce X-rays with a higher mean energy when operated at the same kVp. Additionally, note that the fraction of low-energy photons is lower. With the fewer lower-energy photons, we reduce patient exposure by as much as 35 to 40%. So to summarize, the consistency of X-ray production with short exposure times is useful in digital intraoral imaging. Additionally, it also reduces patient dose. Thus, using a constant potential X-ray units provides us with advantages in intraoral imaging.